Let's look at question 60, permutation sequence. In this question, you will give two input. The first input is n. It means you have an integer array from 1 to n. By this integer array, you can build n factorial size permutation, and from small one to larger one, we have some order. Then give you other parameter k, let you return the kth permutation. So in that one, we give the n is 3, so we have this totally 6 permutation. If k is 2, return this one. So for that question, one solution is you build all the permutation, or try to build each one, and until you reach the k and return it. And the second solution is directly calculate out the kth permutation. How to do it? Let us see this picture. This is n is 4. So in that one, so we know each one start permutation is 6. So this here is 6, here is 6, here is 6, here is 6. Okay, so when k is equal 9, so in that one we know, right? If one start is 6 numbers, two start is 6 numbers. So we immediately can find, okay, our final solution is in the 2 start. So in that one, we know the first letter is 2. Okay, so because the result is not in the first permutations, right? One start permutations. So they located in here. So which one in here? So it's 9 minus 6 is 3. The third one we need to find here, right? Okay, but if let us calculate how we can do it. So we get this out. So we have 1, 3, 4 until 4, 3, 1. From this 6 number, so we have 1, 3, 4, 1, 4, 3, 2, 3, 1, 4, 3, 4, 1, 4, 1, 3, and 4, 3, 1. So we have 1 start, 2 start, 4 start. And then if we want to find the third one, okay, in that one, total size is 2. This one size is 2. This one size is 2. Okay, we know we go to this block. So the second letter is 3. Okay, after we get here, we need to decide 1, 4 or 4, 1, right? And then we have a third one in here. So this one is 2, so we need to select the third. 3 minus 2 is we need to pick up the first one. Okay, if we pick up the first one, we know this letter will be 1. And then finally we only have 4 rest, so we put 4 here. So by this calculate, we find all the letter. So what is calculate? So when n, we get the n and we get the k. So first we need to say this k belong to which n minus 1's factorial, in which one. So we have 6, 12, 18, 24, right? And we check this 9 is in which one. So we will check this k is belong to n minus 1 factorial and all n minus 1 factorial times 2 until n minus 1 factorial times n. So by this way we can find this k belong to which section. Okay, let's ask to start the code. First, we need some help function. It's a recursive function. So we have some recursive call function to do it. And in that one, we will build string builder and return to string. Okay, so first we have string builder, put a result, right? And then the second, so to build the permutation, if we use the 1, and then we know rest thing will be this one, from this one to pick up. So we use some list integer as the numbers, new list, array list, and for I1 and I1 minus equal to n, we put all this number into here. So we put the 1 to n. So for this one we build the permutation. Then every time here we want to calculate this one. So in the beginning we build the all factorial. So we build each number's factorial. Here we use this one. So because the factorial 1 is 1, right? 4 equal to 2. M will be the factorials lines I1 plus plus, right? So from the 2, so the factorial I1 Here's I1. Some typo will be to the I1 minus 1 times I1. Okay, so this one we build all the factorial, and we can continue to use it. So build one time. So call recursive. First is one. The second is we keep this one. So under the numbers, under the n, under the k. So we have the same thing for the function, and list integer numbers and n and k. Okay, so here if this is recursive, if n is equal 1, it's finished recursive. In that one, we get the numbers, the last one. It's only one, that one, right? And return. Otherwise, so next n will be the n minus 1. And then for I1 equal to 1 and I1 is less than n, we do one thing to detect this k belong to which section, right? So we compare each one. So if k is less equal to factorial n next n, right, times I1. If it is less or equal, we find it in which location, and then we find the lighter. So they will add this one, so it should be the numbers remove. If you remove in that location, right, here be careful, we want the I1's location, but this one is 0 based, so we have to minus 1. And in the same time, we remove that element from the list, right? So this list object will automatically remove this location. So next time when you want to pick up the other location, they will continue getting value. And then we do the recursive here. Same thing for the return value, factorials, numbers, and next n and k. K, we already use the value, so k should be the factorials next n times I1 minus 1, right? Y is I1 minus 1. So if you pick up this one, this is I is 2, so you need to minus this 6. If in the 6, you should minus 0, right? So we should do that one, and then we do the break. Okay, let's use this as input to test this function. In the beginning, this is empty. Factorial is everything is good. So 3. For 3, the factorial is use the 2 ones, right? So 3 is bigger than 2, less than 4. So we pick up the 2. Then we pick up the 1, and then pick up the 3. We need to add this one. And let's see what's wrong here. This is 0 based. Okay, here is something wrong. This one will be the 1 based. Okay. And submit it. Okay, so at least we are done. And try one more time. Yeah, sometimes this one will be the 2 ms, sometimes 3, sometimes the 1. For the time complexity, this question, we do the n for this is a big O of n, and come here. So this question time complexity is big O of n, and space also is a big O of n. Thank you for watching the video.